Welcome to a deep dive into the 20 most dangerous minerals ever discovered. While some of these minerals have deadly properties, from toxicity to radioactivity, they remain indispensable to many industries worldwide. Today, we'll explore 20 such minerals, highlighting their dangers, where they're found, and their vital uses. Mineral number 1, asbestos or chrysotile asbestos, is a group of naturally occurring silicate minerals made of thin fibrous crystals. These fibers are extremely hazardous when airborne. Their inhalation can cause severe lung diseases like asbestosis, lung cancer, and mesothelioma, a cancer almost exclusively caused by asbestos exposure. Asbestos deposits are mainly mined in Russia, Kazakhstan, China, Brazil, and Zimbabwe. Despite bans and regulations in many countries, asbestos is still used in specialized fireproofing materials, brake pads, and building insulation due to its excellent resistance to heat and chemical damage. The greatest danger comes from disturbed asbestos-releasing fibers that linger in the air for long periods, making proper mining and handling crucial. Mineral number 2, Arsenopyrite. Arsenopyrite is the most common arsenic mineral and an important source of arsenic, which is highly toxic to humans. When crushed or heated, it can release poisonous arsenic vapors, and weathering of arsenopyrite can leach arsenic into groundwater, leading to widespread contamination and poisoning, especially in mining regions. Major producers are China, Russia, Morocco, Canada, and the United States. Despite the health risks, arsenic extracted from arsenopyrite is used in microelectronics like semiconductors, wood preservatives, and historically in pesticides. The mining operations require strict controls to prevent arsenic pollution in the environment. Mineral number 3, Realgar. Realgar is a bright red arsenic sulfide mineral, toxic through ingestion or inhalation of dust or vapors. It slowly decomposes under light exposure, releasing arsenic gas, which is highly poisonous. Realgar is mined mainly in China, Peru, Greece, Nevada, and Romania. Historically, it was used as a pigment and in traditional medicines, but due to its toxicity, these uses have largely been discontinued. Today, Realgar is studied for its semiconductor properties and potential in photodetectors, though handling requires caution. Mineral number 4, Cinnabar. Cinnabar is the chief ore of mercury and is recognized by its bright red color. When heated or crushed, it emits toxic mercury vapor, which accumulates in living organisms and causes neurological and kidney damage. Notable Cinnabar mining sites include Almaden, Guizhou, Kyrgyzstan, Slovenia, and California. Mercury extracted from cinnabar has been historically used in thermometers, barometers, batteries, and fluorescent lamps. Due to mercury's toxicity and bioaccumulation, many of these uses are being phased out, but cinnabar remains essential for mercury supply in specialized industrial processes. Mineral number 5, Uraninite. Uraninite, also known as pitchblende, is a radioactive mineral containing uranium oxide. It emits alpha, beta, and gamma radiation and produces radon gas, a radioactive carcinogenic gas that can cause lung cancer upon prolonged exposure. The largest uraninite deposits are found in Canada's Athabasca Basin, Kazakhstan, Australia, Niger, and Russia. Uranium extracted from uraninite is the primary fuel for nuclear reactors and atomic weapons. The mining and processing of uraninite require extensive radiation safety measures to protect workers and the environment. Mineral number 6, Galena. Galena is the most important lead ore mineral. It releases toxic lead dust during mining and processing, which can cause lead poisoning affecting the nervous system, kidneys, and blood. Countries like Australia, the USA, Peru, Mexico, and China have large galena deposits. Lead from galena is used extensively in car batteries, ammunition, radiation shielding, and historically in paints and plumbing. Due to lead's toxicity, its use is heavily regulated, and safer alternatives are being developed. Mineral number 7. Stibnite. Stibnite is the main source of antimony, a metalloid with toxic dust and fumes that can cause respiratory and skin problems. Its dust is also flammable and can form explosive mixtures with air. Key mining countries include China, Russia, Bolivia, Tajikistan, and South Africa. Antimony is used primarily as a flame retardant in plastics and textiles, in lead alloys to increase hardness, and in some electronic components. While not as widely known as other minerals, its industrial use is significant, necessitating careful handling to avoid poisoning. Mineral number 8. Orpiment. Orpiment is a yellow arsenic sulfide mineral that is highly toxic if inhaled or ingested. It occurs in hydrothermal veins in hot springs in Turkey, Romania, China, Peru, and the US historically. It was used as a pigment and in traditional medicines, but is now mostly avoided due to its arsenic content. Modern research explores orpiment's semiconductor properties for photovoltaic and electronic applications. Mining and handling are risky because of the potential arsenic exposure. Mineral number 9. Crocoite. Crocoite contains both lead and chromium in its structure, with chromium in the highly toxic hexavalent form, which is a known carcinogen. Its dust is hazardous to inhale or ingest. Major crocoite localities include Tasmania, Russia, Brazil, and South Africa. Chromium extracted from crocoite is critical for producing stainless steel, chrome plating, dyes, and pigments. However, exposure to hexavalent chromium requires stringent industrial hygiene measures due to its health risks. Mineral number 10. Pyrite. Known as fool's gold, pyrite is not directly toxic, but causes environmental hazards through acid mine drainage. When exposed to water and oxygen, pyrite oxidizes to produce sulfuric acid, leading to acidification of rivers and soil contamination near mining sites in the USA, Spain, Peru, China, and Canada. Pyrite is mined as a sulfur source for sulfuric acid production, which is vital in fertilizers, chemicals, and petroleum refining. It's also sometimes used as a gemstone, but environmental concerns dominate its impact. Mineral number 11. Autunite. Autunite is a bright yellow uranium phosphate mineral that emits dangerous alpha radiation and produces radon gas. It's found mainly in uranium-rich regions of Colorado, France, the Czech Republic, Canada, and Portugal. Autunite is primarily an indicator mineral for uranium exploration and is a minor uranium ore. Handling requires radiation protection due to its radioactivity and potential radon release. Mineral number 12. Chalcanthite. Chalcanthite is a bright blue crystalline copper sulfate pentahydrate, highly soluble and toxic if ingested, causing gastrointestinal and systemic copper poisoning. It is found in mines in the USA, Chile, Poland, Spain, and Italy, often forming from oxidized copper deposits. Chalcanthite is widely used as a fungicide and pesticide, as well as a copper source in industrial processes. Its solubility makes it a hazard in mining runoff, requiring environmental safeguards. Mineral number 13. Torbernite. Torbernite is a green, radioactive copper uranium phosphate mineral that emits harmful alpha and beta radiation and produces radon gas. Found in the USA, Czech Republic, Portugal, Germany, and France, Torbernite is an important uranium ore. It is used in uranium extraction and radioactive dating, but is hazardous to mine and store due to its radiation and radon emission. Mineral number 14. Pitchblende. Pitchblende is a dense, black uranium oxide mineral, the most important ore of uranium. It emits strong ionizing radiation and radon gas, both linked to severe health risks, including lung cancer and radiation sickness. Pitchblende mining is concentrated in Canada, the Czech Republic, Germany, Belgium, and the Democratic Republic of Congo. Its uranium is critical for nuclear power plants and weapons but its mining is one of the most tightly regulated due to radiation hazards. Mineral number 15. Bauxite or aluminum ore. Bauxite itself isn't highly toxic, but it can contain impurities like arsenic, fluoride, and heavy metals that pose health and environmental risks during mining and refining. The main producers are Australia, Guinea, Brazil, Jamaica, and India. Bauxite is the principal ore for aluminum, a lightweight metal essential for aerospace, packaging, transportation, and construction industries. The refining process generates toxic red mud waste, posing serious environmental challenges. Mineral number 16. Fluorite. Fluorite mining occurs in China, Mexico, South Africa, Mongolia, and Russia. While not highly toxic itself, it can release hazardous hydrofluoric acid during processing, posing serious chemical burn risks. Fluorite is vital for producing hydrofluoric acid used in chemical manufacturing, glass etching, and steel production. Mineral number 17. Cobaltite. Cobaltite contains cobalt and arsenic, making it toxic and hazardous to mine. Major producers include the Democratic Republic of Congo, Russia, Canada, and Australia. Cobalt is crucial for rechargeable batteries, aerospace alloys, and catalysts. But arsenic's toxicity requires careful environmental and worker safety measures. Mineral number 18. Beryllonite. Found in the USA, Canada, and Namibia, Beryllonite contains beryllium, a toxic metal that can cause chronic beryllium disease when inhaled. Used in aerospace and nuclear industries for its lightweight and stiffness, beryllium mining demands strict health protocols due to its toxicity. Mineral number 19. Realgar. In addition to being highly toxic, Realgar's degradation under light releases arsenic gas, complicating storage and handling. Realgar crystals are found in hydrothermal deposits mainly in China and Peru, and the mineral is studied for its photoactive properties despite its risks. Mineral number 20. Colemanite. Colemanite is a borate mineral mined in Turkey, U.S. and Argentina. It can cause irritation if inhaled as dust and poses moderate chemical hazards. Colemanite is important in glass and ceramics manufacturing and as a boron source for agriculture and detergents. These 20 minerals illustrate the paradox of mining. Dangerous substances essential for modern technology, energy, and industry. From deadly asbestos fibers and radioactive uranium ores to toxic heavy metals, mining and handling these minerals demand stringent safety protocols and environmental protections to safeguard human health and ecosystems. If this video opened your eyes to the hidden dangers and incredible utilities of these minerals, please give it a like, subscribe, and click the notification bell for more fascinating science content. Which mineral surprised you most? Let me know in the comments. Thanks for watching, and remember, knowledge is power. Stay curious and stay safe.